Okay, I chose to do a continuing education presentation on molecular diagnostics. In this, what we were looking for are genetic markers for bacteria, viruses, or genetic diseases. And specifically inside these organisms, whether it's the invader or us, we are looking for genes, specific genes that are associated with these conditions, well, genes or alleles of genes if we're looking to differentiate different strains or identify alleles associated with a genetic disorder. Genetic diseases, they can be either inherited or they can come from spontaneous mutations. If they're inherited, you can look at family history to determine if somebody should be tested for the presence of the allele or gene, to know if they're an asymptomatic carrier or if they're simply asymptomatic. For bacteria and viruses, we can be looking for a specific strain. In the case of MRSA, looking for the plasmids that carry the resistance, give the resistance to the drug, antibiotic. For viruses, you can be looking for extranuclear DNA or intranuclear, where they insert their genes into our genome. Samples, you can use whole blood, serum, plasma, sputum, swabbed samples, urine, tissue. Each one has their own requirements leading up to it and for processing it to extract the genetic material. And once the genetic material has been extracted, there's a number of different methods we can use to identify what that material can tell us. In this case, I chose PCR. PCR, you denature the DNA, separate it. You have the annealing stage where you add the primers. After you cool it down, the enzymes run through, replicate, heat it up again, denature, cool it down, replicate. You can also have next-gen sequencing, microarrays, or FISH. And once we get that information, how do we know it's useful? There's a lot of databases that we can use to assess that.